Welcome. In this video, we will be taking a look at a special integral, the integral of the natural log of x function. So we're going to accomplish this integral using the integration by parts technique. So let's remember and remind ourselves what the integration by parts is all about. We are going to take an integral to start out with of the form u dv. And this, by the integration by parts, is going to be the u times the v function minus the integral of v du. So we can work with this integration by parts technique to solve our natural log antiderivative. And this will be definitely helpful for us as a result as we move forward looking at more complex natural log integrals. So let's consider first what our u and our dv function will be in this integral. And again, from those, we're going to make our dv function and our v function. So let's start with the u. There's really only one option to choose for the u function, and that is natural log itself. So natural log of x, and that will make our dv just dx. Again, we want to account for everything in our integral with the u and the dv. So we've got that covered. Now let's take a derivative of our u function, let's call it du. The derivative of ln x we know is 1 over x dx. And then our antiderivative of dv to find our v function. Well, the antiderivative of 1 dx, this is really 1 dx if you want, will just be x. So I have all four components there solved out. And with any integration by parts, again, to remind myself of the equation, if I don't have it handy, I can always just make my arrows. So u to v is the product, and then we're going to subtract the integral of v du. So make an arrow diagonally u to v, and then my arrow across v to du. So let's set up the next step of the integration by parts. The v and the u will be x times natural log of x. That's my first term. And then I'm subtracting the integral of v, which is an x, times 1 over x dx. And we'll notice this is coming out pretty cleanly for the second integral. X times 1 over x, these will cancel, and we'll just be left with 1 over 1. And so the integral of 1, well, we just solved that in our dv. We know that is just going to reproduce a x. So here I can rewrite this as x ln x minus this whole integral of 1 dx is going to be x itself. And then again, I can add my plus constant c on because I have an indefinite integral. So this is our result for the antiderivative for the natural log of x function. So this is a good one to remember for future examples you might see or problems in your homework. So remember, our natural log antiderivative will be x ln x minus x plus c. So hope this is a good video for you guys, and look forward to seeing you guys in the next one.